Pesticides are an essential input in agriculture, and they are widely used around the world. The pesticides market is over $100 billion a year and is rapidly growing. However, pesticides for growers represent a major part of the production cost that can be up to 50%, and these are also toxic products that can harm the environment. When pesticides run off, they can pollute soils and water sources and cause a lot of health issues. And actually, around 200,000 deaths per year are linked to pesticide poisoning around the world. The major problem with this is that the spraying of pesticides is very inefficient. And a study found that only 2% of sprayed chemicals end up on their intended target. 98% goes away. And one of the main reasons for that is that a lot of plants are hydrophobic or water repelling. So when you spray these chemicals on them, they just bounce or roll off the surface and end up in the soil. At MIT, we've been developing a solution to this problem using polyelectrolytes or charged polymers that we spray simultaneously from two nozzles on the surface of the leaf. And when these droplets from these two solutions combine and coalesce on the surface, they form hydrophilic precipitates on the surface that are on the order of a micron. And these sparse precipitates can pin the droplets and prevent them from bouncing. So droplets become anchored to the surface, and we can have a much better coverage. So as you can see, when you spray water on a hydrophobic leaf, droplets just bead up and easily roll off the surface. But when we spray our polyelectrolytes, we can form a uniform film that covers the surface. So in our experiments, we showed up to a 10 times increase in retention, which in practice means a 10 times reduction in pesticide needs. We also have an enhanced protection because we have a uniform coverage now, and we have a reduction in runoff and pollution. The polymers we use are natural. They are all plant or animal extracts, and they are biodegradable, so they won't contribute to additional pollution. The work has been, so part of this work has been published in Nature Communications, and we have 3 patents pending around this work. So the market for this is about, total addressable market is about $15 billion annually. And to start targeting that market, we will focus on a beachhead market comprising the 2 or 3 crops that have high pesticide costs and are hydrophobic, so the ones that suffer most from this problem. And an example of that is the US cotton market, which is a $150 million opportunity. And beyond these solutions, we'll be able to provide advice to growers on spray usage, as well as collect data and optimize the process with data-driven solutions. So if we look at the competitors, this solution is very cheap to make. It's a very tiny fraction of the value it would provide to the growers. The main other solution that's used right now is surfactants, which have been proven to be not that efficient, and they have also other disadvantages and environmental aspects. So we've talked to several people in the industry about this, potential customers, people who manufacture chemicals, and people who are in the spray industry in general, and we have received great feedback. This is our timeline. Right now, we have been working on the development of these polymers for the past few years, and we are still working on that in the lab. We're also starting some field trials with partners. And as soon as we get some results from these field trials, we'll be able to spin out and start launching this product. So about these field trials, this is one of them that we are starting on grapes. So you can see the difference between just spraying just water and the polymers. So we've been working with a partner in Italy. We did some preliminary testing with them, and right now we are starting a trial from now till September over a whole season to test the efficacy. Another trial we're doing is with citrus trees, so with a partner in Florida. It's also starting in the next 2 to 3 weeks. And they sent us a few trees that we've experimented on at MIT. We've had very positive results, and we haven't observed any phytotoxicity, which has been one of the questions we got a lot, so that was encouraging, and we are starting the full-scale trial soon. So for now, the team is me. My name is Maher Damag, and my PhD advisor, Professor Varanasi. But especially when we launch this, we'll be looking at growing the team. So if you know anyone who is qualified and interested, please let me know. And in the 30 seconds I have left, apart from these possible partners, I would like to ask you if you know any potential customers, any growers who might be interested in testing this, or even to talking to us. We are always looking to people to talk to improve the product and get their feedback. Industry experts I already mentioned, and possible partners either in the chemical industry or in the making of sprayers. Anything that can be relevant, we'll be happy to talk. So yeah, I have a poster here, and happy to chat with you further and talk about our mission to eliminate pesticide waste, keep our environment clean, and save growers billions of dollars a year. Thank you.